Hello everyone, welcome back to our YouTube channel. In this video we are going to see how to write the CMOS structure for the various gates as well as for the various complex equation. First we will start with the 2-input NAND gate. First step is to write the truth table for the given expression. For NAND gate we have to write the truth table. We have to see for what input we are getting output as 1, that is considered as PMOS, and for output as 0 we are considering it as the NMOS. And here we can see it is the OR logic for PMOS, and for OR we have to consider the parallel, that is the PMOS should be in parallel, that is A and B input, and for NMOS it is the AND logic which should be in series. PMOS and NMOS are the dual circuits, that is they are complementary to each other, and later we have to join these two PMOS and NMOS circuitry and form the CMOS circuit. This is how we easily write the CMOS circuit for the NAND gate. Next is, let's see the same for the NOR gate. First, as I already said, we have to write the truth table for the NOR gate, and here you can see it is output is 1 only for that is for 0 0, that is considered as PMOS, and for PMOS this is AND logic, and AND is in always should be constructed in series, and for the NMOS you can see it is the OR logic and it should be written in parallel. We should write the PMOS that is in series and the dual of that for NMOS and join these two to get the CMOS circuit for 2-input NOR gate. We'll see how to write for the complex logic circuit for any expression given. For example, y is equal to a into b plus c whole bar. First step is to write the truth table, then we have to group ones and zeros, that is for what input we are getting as 1 and for what input we are getting as 0. Then we should write this expression in the K map and we'll get the expression for y as something like this. Whatever expression we get into 1, that is by grouping 1, we should consider it as for the PMOS and draw the circuit for PMOS, that is if it is AND logic then B and C should be in series and A is also in series with 1, and these two separated by plus sign, that is OR of that, it should be constructed in parallel, that is BC and A are in parallel to each other. This is the PMOS circuit. In similar way, the complement of this should be considered for while constructing the NMOS, and later we have to join this to get the complementary CMOS. Next we'll be seeing what are the characteristics of the CMOS circuits. NMOS and PMOS networks are dual of each other, that is if one is in series, other should be converted to parallel, intrinsically inverting in nature. For N input logic, 2 N MOSFETs are required, that is N NMOS are required and N PMOS are required. How exactly we can write the CMOS circuit? For example, here one expression is given, that is y is equal to AB plus CD. Now number of N MOSFETs is equal to number of P MOSFETs, which is equal to number of the Boolean variables, that is 4 in this case. Now we have to equate this y is equal to 0, that time we'll get as AB plus CD as 1. So we have to use active high switches, that is N MOSFETs. For AND logic, series connections of switches, and for OR logic is nothing but the parallel connection of switches. By following this step, we have to construct this A and B are AND, that's why they are in series, and C and D also in series. Then we have to add A, B and CD in parallel to each other. This forms the NMOS network. For the same circuit of NMOS, we are writing the dual circuitry of the PMOS, that is A and B are now in parallel and C and D also, and then these two should be in series, therefore we are connecting it in this manner. The combination of the NMOS and PMOS network, we obtain the CMOS circuit. Now we'll combine both PMOS and NMOS circuit and we can obtain the CMOS circuit for the given expression. We will see how to write the structured approach. There are two types, that is AOI structure and OAI structure. In AOI structure, first and or and inverter, that is and or and of two should be combined using or operation, and finally the inversion operation, that is whole bar. In the case of OAI, it is nothing but and of two or operation and whole bar, that is inverter operation on it. Using the similar approach, we can write the CMOS circuit for the AOI structure as well as OAI structure as shown here. Next, we'll consider the XOR and XNOR gate using that is AOI structure of these two gates. This also depends on how you write the expression. For AOI, we have to write that is the OR expression of two and expression, that is AB plus A bar B bar whole bar, that comes to be XOR gate. Similarly, AB bar plus A bar B whole bar comes to be XNOR gate, and following the similar approach you can write the CMOS circuit. The similar way for OAI structure, can write the XOR and XNOR gate, that is by AND logic of two OR expressions we can write the CMOS circuit. Next is the generalized AOI and OAI gates. How we can write these gates? If AOI 2 gate is asked, 2 represents the two inputs for the first AND gate, and here also in the second figure you can see 2 input OR gate and 2 input OR gate. In the third figure you can see 3 2 1, that is 3 input AND gate, 2 input AND gate and 1 input. In that way you can write the structure of AOI as well as OAI depending on the name given. Can also try writing the CMOS circuit for following examples. Using similar approach you can write easily. For more such videos, do subscribe to our channel. Thank you for watching.